And the law of cosines will be used in conjunction with the law of sines to solve triangles where two sides and the included angle are known. Or in cases where all three sides are known. So the law of cosines states that if A, B, and C are the measures of the angle of a triangle, and A, B, and C are the lengths of the sides opposite these angles, like we saw earlier underneath the law of sines, then A squared is equal to B squared plus C squared minus 2BC cosine of A, or B squared is equal to A squared plus C squared minus 2AB cosine of B. Oh, whoops, made a mistake here. I'm sorry about that. So we have 2AC cosine of B, or we have C squared is equal to A squared plus B squared minus 2AB cosine of C. So roughly the square of a side of a triangle is equal to the sum of the squares of the other two sides minus twice the product times the cosine of their included angle. So we can use this formula in conjunction, these formulas in conjunction with the law of sines to solve an SAS triangle or an SSS triangle. So let's take a look at a SAS triangle. So step one, we're going to use the law of cosines to find the side opposite the given angle. Step two, we're going to use the law of sines to find the angle opposite the shorter of two given sides. This angle is always acute. And then step three, we're going to find the third angle by subtracting the measure of the given angle and the angle from step two from 180 degrees. So let's take a look at both. So let's take a look at example here. Here we have a side triangle. As you can see, we have side B, we have angle A, we have angle C. So step one, if you remember, is to use the law of cosines to find the side opposite the given angle. So we have side B, we have side C, we have angle A, so we can use A squared is equal to B squared plus C squared minus 2BC cosine of A. So now we're just going to plug in numbers. We have A squared is equal to 20 squared plus 30 squared minus 2 times 20 times 30 times cosine of 60. And this gives us 400 plus 900 minus 1200 times 0.5. And that's going to be equal to 700. So side A is going to be square root of 700, which is going to be approximately 26.5. So now we can use the law of sines to find the angle opposite the shorter of the two given sides, which this angle will always be acute. And so the shorter of two given sides is 20. So we'll use the law of sine, which we have sine b over sine b is equal to a over sine a. That gives us 20 over sine b, which is equal to a, which we got earlier, is 26.5 over sine of 60 degrees. So now we just calculate this all out. We get square root of 700, which is multiplied by sine b, which is equal to 20 times sine of 60 degrees. We solve for sine b, 20 times sine of 60 over square root of 700, which is also 26.5, and this is going to give us approximately 0.6547. Now if we go on our calculator, if you have a scientific calculator, you're using a TI like me, you're going to press the second, you're going to go for second to square root of negative 1. That's going to give us 40.896. So from here we know that our B angle is approximately 41 degrees. And from here, because we now have angle A and angle B, we can now use this to figure out angle C. So what we're going to do is we're going to subtract A and B from 180. So we have C is equal to 180 minus A minus B, which is going to be 180 minus 60 minus 41, which is going to give us 79. So C is equal to 79. We now have our three angles. A is equal to 60 degrees, B is equal to 41 degrees, C is equal to 79 degrees. We have all three sides. A is equal to 26.5, B is equal to 20, and then C is equal to 30. And for our final example, we're going to solve a SAS triangle. So the example that's given, we have a triangle that looks like this. We have side A, side B, and side C, but we don't have any information for our angles. We do have information for our sides. Side A is equal to 6, side B is equal to 9, and side C is equal to 4. So step 1, use law of cosine to find the angle opposite the longest side. So in this case, our longest side is going to be 9. So we're going to calculate for angle B down here. So we're going to use the following formula. B squared is equal to A squared plus C squared minus 2AB, minus 2AC cosine of B, and we're just going to isolate cosine of B on one side. So what we're going to get is we're going to get 2AC cosine of B is equal to A squared plus C squared minus B squared. Then we're going to divide both sides by 2AC to isolate the cosine of B by itself. And now we can just plug in numbers. And that's going to give us negative 29 over 48. And now we're just going to do this. Which is going to be approximately 53 degrees. And because our cosine of b here, this number is a negative, this means that b is going to be an obtuse angle. And because b is an obtuse angle, we're going to be subtracting 53 from 180. So we're going to get b is equal to 180 minus 53, which gives us 127. So from here, we can use the law of sine to find either of the two remaining angles. In this case, we'll solve for angle A. So our law of sines gives us A over sine A is equal to B over sine B. Now we're going to plug in our numbers. And now we'll cross multiply. Now we'll divide both sides by 9. Which is going to give us approximately 0.5324. And if we punch this into our calculator, that's going to give us roughly 32. So we know angle A is approximately 32 degrees. And now all we have remaining is angle C. And because we have angle A and angle B, we can just subtract both of those from 180. So this will be 180 minus 127 minus 32, which is going to give us 21. So for angle C, we have 21. And now we have the numbers for all three sides as well as all three angles. And there's one more formula to this section. It's Heron's formula. And it can be used to find the area of a triangle in terms of the lengths of its sides. And this is what it looks like. Area is equal to square root of s times s minus a times s minus b times s minus c, where s is equal to 1/2 its perimeter with sides a, b, and c. So s is equal to 1/2 a plus b plus c. And if we have an example where a is equal to 12, b is equal to 16, c is equal to 24. We can begin by calculating 1/2 the perimeter. So s is equal to 1/2 a plus b plus c, which is equal to 1/2 12 plus 16 plus 24, which gives us 26. And now we can use Heron's formula to find the area. So area, as we noted up top, it's going to be square root of s times s minus a times s minus b times s minus c. And now we're just going to plug in numbers. It's going to give us the square root of 7280, which is going to be approximately 85. So the area of the triangle is going to be approximately 85.